So now what we're going to do, we're going to do the calculation aspect, alright, and how do we use the moments formula and principle of moments. Okay, so you look at question 1 on the next page. Okay, says there what? The diagram shows a uniform plank. Okay, 140 cm, weight 25 newtons. So when uniform means it tells you this thing, that the center of gravity is in the center. And it is the center, that means the weight of the plank acts on the center. Okay? So you see here the weight is 25 newtons. The weight of the plank. So that's why you see here is labeled is 140 cm long. That means the center of gravity is how many cm away? The plank is 140 cm. So this is 70. The cm missing. Okay. Now this question, then after they say there's one force at 80 newtons acting at y, then they draw another force at p. Okay. This diagram drew almost all the forces for you. There's one force missing. Where is it? Normal reaction force. Okay, where is it? Okay, good. At the pivot. So I label here. Okay, let's label it normal reaction force. Normal reaction force. Okay, so for any kind of question you get a calculation aspect, first thing you do, look at the diagram, label all the forces. They never label for you. Here they label for you everything already, except the normal reaction force. Okay? Then typically there are two questions, two style of questions. Part A. Calculate the moment of the turning effect due to the 80 Newton force about the pivot. Okay, how do you do this? So what are they asking you? They're asking you how much is the turning effect due to 80 Newton force. So what do? Use what formula? Yes. Okay, so what you do, Jonathan, write this down. Moments equals force and distance. Simple working. Then after that? That means take distance to the pivot here. Okay, so you tell me what's the force? What's the force? 80. Okay, 80. Then what's the distance? 130. 80 to the pivot. 100, right? Okay, good. 8,000 is the answer. What's your unit? Okay, so this is the first style of question where they ask you what's the turning effect due to a certain force. Got it? Okay, then the next style of question is this. I will ask you calculate the force F, okay, if you want everything to balance. So what must this force P, okay, this force P be in order for this whole thing to balance? Alright? So this is your style of working. Look, you write this down. Take moments about pivot. Okay? Then the next line you write, what is the condition for everything to balance? Something must equal something. What is something? What's the condition for everything to balance? Something equals something. So then you write down this. Anti-clockwise moments equals clockwise moments. Wait. Got it, huh? Okay. Then now, you're going to do the working. You see here, you have already labeled all the forces. That's why I say it's very important you must label the forces. If you never label for you, you must label. Then, Jonathan, you're going to see that it's actually quite easy. Now you go through each force, one at a time. Force P. Wait. Force P. Wait.
Yeah.
Clockwise or anti-clockwise?
Anti-clockwise.
Left or right? I write it over here. You write there. Force P. What's the distance?
30.
To the pivot, 30. Good. So I write there times 30. Next. Normal reaction force about the pivot. Any moments? The normal reaction force, any moments? No. Why? Because you're on the pivot, right? Okay, so this one don't care. Next, 25 newtons, clockwise and anti-clockwise? Left or right? Okay, 25 times what? Be very careful with distance. Normally your error will be the distance. You don't tell me 70, you don't tell me 30, you tell me 40 because it's to the pivot. Alright. So put as 40. Then, is this complete?
No, still got 80.
Yeah, still got 80. Clockwise and anti-clockwise? Left or right?
Right.
Okay. You press your calculator. Okay, so you show your working, you get force P is 300 newtons, right?
Yeah.
Was it very difficult? Easy, right? So you see what's the problem? Not much problem, right? So you just follow this method as I said. Okay? Write these two lines, go through each force, ask yourself clockwise, anti-clockwise, be very careful with the distance, do your working, you get answer. Okay, now, if I ask you, part C, calculate the normal reaction force. How? Remember the next condition. The one more condition is what? The upward forces equals to the upward equals so if I very good. So NRF, okay, short form, normal reaction force equals to 300 plus what?
Plus
25 plus 80. So what is the answer? 405, right? Okay, 405 newtons. Okay, so you see, there are two ways you can solve. You can say take moments about pivot, or if sometimes this helpful, upward force equals downward force. It can help you solve it. Okay. Okay, so it's not very difficult. Okay, now you try question 2. Okay, question 2. Write down. Tell me what to write.
Take moment about pivot. What do you don't like take moment about pivot in exam?
I encourage you to do it so that you will.
But there's no point in that.
There will be. It makes more sense to your working, and you are less likely to go wrong. Okay, which is the anti-clockwise?
The anti-clockwise is the force.
Okay, so on the left side, F times.
34 plus 80.
Very good. This is where a lot of people go wrong. But you didn't. So that's good. That's the distance to the pivot. So equals to 120 times. Okay, so according to you, F is 51, right? So what does this mean? It simply means you put 51 newtons here acting outwards, the leg will balance. Okay? So you see, it's not very difficult one. Okay. Okay, next, look at question 3. Okay, so for question 3, calculate the anti-clockwise moment first.
Okay.
What times what? 30 times
30 times
0.7.
0.7. 1. Then 0.2 times 100 is 20. Then 21 minus 20 equals 1.
So 21 Newton meter, right? Then clockwise moment, force and distance, 100 times
Times 0.2.
which is
120.
okay. So the resultant moment, so the resultant is clockwise or anti-clockwise?
Clockwise. No, anti-clockwise. Wait, but how the 30 meters? Oh yeah, okay.
Right? So that means it's an anti-clockwise resultant moment. So you see a little bit different style, but it's not difficult at all. Okay, so far so good. Next, question 4. Okay, so the first one, part A, you say just use the moments formula because they're asking you to calculate the moment due to 15 Newton force. So 15 times, it's not 75, it's not 50, it is times the distance of, what's the distance? 25, right? What is the calculator value? Units? Okay, now part B. Maybe part B is harder. So, write the two lines again. Anti-clockwise moments equals clockwise moments. Okay, so you're gonna put the what? The 20 Newton on the left side, right? So somewhere here, the 20 Newtons must be somewhere here. So the 20 Newtons create clockwise and anti-clockwise.
Anti-clockwise.
So 20 times the distance of don't know what, right? Then the clockwise is the 15 Newton, right?
Yeah.
So it's 15 times 25. What's the answer you get for this?
70.75 around that.
And then divide by 20.
375 divided by 20 is 70%. 18.75. So it's 18.8.
18.8. Okay, good. Okay. Okay, very good. Very straightforward so far. Okay, now next one. Huh?
Mass of the bridge on the car is 900 kilograms. Constant force exerted by the point A
Is how much? Or you read halfway and you stop. It's what?
the contact force exerted by point A on the bridge is 4.5 kilonewtons.
5.4 lah. What for? You read your all the way around.
Calculate the magnitude of the force FB exerted by the point B in the value of X. Assume the mass of the bridge is negligible. Answer 3.6 kilonewtons for 1 kilonewtons.
Okay, so I show you that it's actually not too difficult, Jonathan. What you need to do is label all the forces with information you are given. Okay,
We have the color point
where the car is how much?
900
900 what?
kilograms, which is 9,000 meters.
Yeah, so draw here like that. Label one of them.
Assume that the mass of the bridge is negligible.
Okay, so don't care about the weight of the bridge, so that one don't have to
So you only
bother.
have force reaction.
Then they told you one more force. Where is it?
Contact force exerted by a point near the bridge is 4.5 meters.
Hey, read properly lah. What is this?
Contact 4.5 kilonewtons.
Why do you read opposite?
Oh, 5.4.
Jonathan! You can't read 5.4, you 4.4 is 4.5. Huh? Okay, so what do? You label here the contact force is actually a normal reaction force, right? 5.4, okay, write down 5.4 newtons. Okay? There's still one more force. Where is it?
One more force.
Where?
B.
B.
Also 5.4.
No,
How will you know B?
it's not 5.4. It's unknown.
Oh.
You don't know. Okay? You don't know what is it. Okay? But you can easily find it out. Okay. So you first step label all the forces. Alright? Now they ask you to find force B. How do you do that? What can you do? They label the total length of the bridge is 1 km, which is 1000 meters. Okay, so now you are going to take moments about A. Okay, try taking moments. It's not anti-clockwise equals clockwise. There are too many unknowns. So what you do, you apply the second condition for everything to balance. The outward forces equals to the
Downward force.
okay. Okay, what are the outward forces? What's the outward forces?
Outward forces are 4.5 meters.
Why do you read things
5.4
opposite?
meters plus FB equals to
Equals to? What's the downward?
9,000.
Okay. Minus away.
9,000 minus 5.4.
You gave 4.5. Huh?
889.
889.
899.
Jonathan, 5.4 kilonewtons.
Oh, 5.4 times 1,000. So 9,000. And this answer 3600.
Okay. 3600, Okay. Can. So apply this condition. The upward force equals downward force. So much easier. Very fast can get answer. Okay, how do you find the x now? How do you find x? Take moments for where?
Clockwise.
Say properly. Take moments for where? A or B?
A.
Okay. That's why I tell you to write down first. Don't press calculator. Don't think mentally. Just write down first. Take moments for A. Then you say anti-clockwise moments equals clockwise moments. Okay. Then you ask yourself. Look at each force. Look at each force. This one. Clockwise or anti-clockwise? About A. Does this have any moments?
Yeah.
5.4.
5.4.
Does it have any moments about A?
No.
Because it's on the pivot, right?
Yeah.
Okay, so this one don't care. Next, this one.
9,000
Clockwise. Okay, so clockwise or anti-clockwise?
clockwise.
Okay, then you come to this side, you write there 9,000 times
9,000 times
X. Alright?
X.
Okay. Then FB, which is how much?
FB 3600.
Okay.
3.6 kilonewton.
3.6 kilonewton, clockwise, anti-clockwise.
No, anti-clockwise.
Okay, what's the distance?
1000.
You see? Simple, right? The working. You cannot see, never say anything. Simple, right? Working is simple enough. So the answer is 400 newtons. So question 6. Look at the question, uniform plank, which is, okay, you read the question and then after that label all the forces. Remember, it's very crucial to label correctly. Okay, label all the forces and then do A part D and A part A and part. Tell me what are the forces?
Weight of the apples and weight of the plank.
Which is how much?
3 kg.
No, wrong,
Or 5 kg.
wrong.
What?
Weight is not kg.
Oh, 550.
50 newtons is the
Weight of the apple.
and
And then that.
still at the weight of the plank, right?
Yeah, so 80 newtons.
Okay, write down 80 newtons. Okay, that's one force. How far is it from the pivot?
It's 0.5
Good.
cm.
How you know? Because they say uniform plank.
Yeah.
Okay? Now there's one more force. Where is it?
Force acting by the friction.
No friction. Force acting on the plank. There's no friction on the plank.
Force needed by the farmer.
There is a force here. What is the name of this force?
Force reaction.
Reaction force, normal reaction force, okay? So there are actually 3 forces.
Why does it have the normal reaction?
Because the reaction, the plank exerts a force on the wheel exerts a force there on the plank.
Or to carry the plank.
It's a reaction force, okay? Okay, so you see, you always must label the correct forces correctly. You label wrongly, you cannot do the questions. Okay, now you do part D. Okay, you write down, take moments about the wheel. Then after that, anti-clockwise moments equals clockwise moments. So the 80 newtons clockwise and anti-clockwise. The 80 newtons clockwise and anti-clockwise.
This one? Clockwise.
This one,
Oh, clockwise.
clockwise. So 80 times how much? Distance?
0.5.
Okay. Then this force F, clockwise and anti-clockwise.
Force. And 1.
Do we have to care about the normal reaction force?
That's 80 times 0.5 is 40 or 40 1
Yeah, we get 40, correct. But do we have to care about this one? Any moments? No, right? Okay, because of the pivot. Okay, good. So, if you didn't label the force correctly, you get this question wrong. So it's very important you label it correctly. Okay, now, part D, think on some common sense. What happens if the apples are placed closer to the wheel? The force needed, will it be more or will it be less? So all the apples he shifted closer to the wheel. You ask yourself, physics terms, will the clockwise moments be more or will the clockwise moments be less? So shift all these apples closer here. So this clockwise moment now will be more or less? Yes. Okay. The clockwise moments due to the apples will now be reduced. Okay, so you think the force F will be more or less?
More. Less.
Less, right? Correct, right? Less, right? Because why? Because this distance became smaller. That means this whole value became smaller. This one don't change. So this will also be less. Right? Correct. So then you write like that. The clockwise movement due to apples will now be reduced. Hence, the force F required will be also lesser. Right? Okay. So sometimes you also need to know how to explain questions like this, not just all calculations. Also need to how to explain. If you look at question 7, read it. 7, read it. I think Dylan and Shahir should have no problem with 7A. I don't know whether you, Jonathan, can do it. Anyway, you read the question, label all the forces, label all the distances. Important words. Okay, so action reaction pair, the force, or rather the Planck exerts a force on the Newton meter. Okay, so you identify the two bodies. One is a Planck, one is a Newton meter. Okay, which Newton meter you can say A or B, up to you lah. Okay. Then after that, so this is the action. Jonathan, this is the action. The Planck exerts a force on the Newton meter, and the reaction is, and the Newton meter A exerts, and what are the important two words you must have? Equal, one more word, and opposite force back on which one?
The whole thing.
What's the whole thing lah? You see, I already tell you, right?
Back on the Planck.
On the Planck, yes, the Planck, yeah. Back on the Planck. Okay, so that's how you identify and that's how you write it down. Okay, so write it down like this. Then after that, before you do part B, you need to draw all the forces acting on this Planck. It's non-uniform, you cannot say it's at the center lah. Okay, so non-uniform means that the weight is somewhere, you don't know where, but maybe let's say to the left somewhere here like that. Okay, so we draw one arrow like that, and then we say the weight. Are you given the weight of the Planck?
No. Oh wait, yeah.
How much?
950.
Okay, then you label one of them. Okay, there are two more forces. Where are they?
Force meter A records 570 and calculate the relief on force meter B.
Okay, so where are the two other forces?
Force meter A and B.
Okay, so you go to force meter A, you draw a force up or down?
Up.
Okay, up. Then this one is how much?
Don't know.
Don't know Are you sure or not? What's the value?
570 and
Okay. Then
force meter B. Don't know.
up or down?
Up.
Okay, up. So this one don't know, we just write there force B. Okay. Force B. Okay, now do the question. B part 1. So you are doing the upward forces equals the downward forces. Upward forces. Jonathan, which are the upward forces?
The outward forces.
What are they? Yes, which is the outward? Quick, tell me.
Outward force down. upward is 570 plus B.
Okay, so you're working like that. Then the downward?
Downward force is 950.
Okay, do some simple maths. What do you get?
380.
Very good. Okay, so you think of the approach. Either use upward force equal downward force, or you take moments. Okay, now you look at the part 2. Step 1, read the question, label where X is. This is the what you want to find. X, which is the distance or center of gravity from the P, from the NP. So the weight is there, then X is to P lah. Okay? Take moments about force meter B.
Clockwise, anti-clockwise is 380 times.
How much?
Times 2.5 minus 0.4. 2.1.
Hey, start again and stop sneezing. 570 clockwise or anti-clockwise?
2.5
Hey,
minus 0.4.
this one 570. Tell me clockwise or anti-clockwise?
Clockwise. No, anti-clockwise.
B is here, no? The pivot is here, no? You say the pivot here. This is clockwise or anti-clockwise?
Oh, that cannot use B.
Huh?
Cannot use
You don't want to use B now. Okay, you want to use where now? Change your mind. Where you want to use?
B.
You can use B. It's fine.
You can use B.
Okay.
Anti-clockwise.
570 is clockwise or anti-clockwise?
Clockwise.
Clockwise. Okay, so I write here clockwise. Okay, now you must get the distance correct. 570 times what?
570 times 0.50 minus 0.8.
Okay, very good. You got the distance correct. So you are saying the distance is from here to here. 2.5 times minus 0.8, which is
380 times
1.7 meters, right? Am I right?
570 times 1.7.
Okay. Next, look at the next force. Wait, 950. What's the distance?
950.
And there's an X here, more confusing.
Oh. Wait. I don't think. 1.7 is wait. No, 1.7 minus 0.4. 950.
No. Look at the X here.
Yeah.
There's an X here. That means here to here is what distance?
0.4. Wait, X.
Here to here is X. Here to here is 1.7. That means here to here is how much?
1.7 minus X.
1.7 minus
X.
X. Very confusing, right? I tell you what, make it easier. Okay, let's put here to here. Let's call this Z. Okay, we find Z first, then we can find X. Okay, so
X equals to 2.1.
so 950 times Z, right?
Yeah.
Okay, so 950 times Z. Okay, now solve this, tell me what's the answer. Z equals
570 times 1.7. Then 6 divided by 950. Let's see. 1.02. Okay.
Z is 1.02,
Yeah.
So you say Z is 1.02 meters. Okay. So what is X now?
So 2.1 minus 1.02. 1.08.
So X is equals to, okay, X plus Z plus 0.4 equals 2.5. So
2.5 minus 1.4 equals
So X equals to 1.0.
2.
Wait, something is wrong.
1.02.
No. Do your calculation correctly, you should get 1.08. See, X, follow my working. X, here is X. X plus Z, right? Z is already X plus Z plus 0.4 give you 2.5. So X plus 1.02 which we found plus 0.4 equals 2.5. Minus everything, you get X equals 1.08. Okay? So you could do it this way, take moments of B. It's confusing but can be done. Right? Or you could have done it another way. Okay, I show you. Okay, or we do together. Okay, let's try this, then we will end here already. Okay, let's try copy down the working. Okay, take moments about P. Take moments about P. Anti-clockwise moment equals clockwise moments. Okay, about P here. So imagine the pivot is here. So this one, first one, 570, clockwise and anti-clockwise. So imagine the pivot is at P, clockwise and anti-clockwise.
Clockwise.
This is up, no. The P is here, the pivot, no.
Oh, pivot is P, anti-clockwise.
So 570 times,
Times 0.4.
okay. Let's do this faster. 950, clockwise and anti-clockwise.
Clockwise.
So I write on the other side, times what?
950 times X.
Good. Then after that,
Oh, okay.
FB. Clockwise and anti-clockwise.
Clockwise. No, anti-clockwise.
Okay, 950 times how much?
950 times X. Equals 950 X.
No, it's not 950 times X. Here to here, the whole thing is 2.5. So here is 0.4. That means here to here is 2.1, right?
Yeah,
Okay. Now you press your calculator.
I can see.
You press your calculator. You tell me what you get for X. You shoot
570 times
0.4 plus 950 times 2.1.
Plus 950 times 2.1
Divided by.
divided by 950.
How come? Wait, I got how come? Hey, sorry. Made a mistake. This is not 950. This is 380.
Oh,
Okay, press calculator again. Mistake, sorry. This is not 950. This is 380.
plus 380 times 2.1 divided by 950. 1.08.
So we get 1.08. You see that? Okay, so what you see here, you can take moment of P, it would have been a bit easier lah. Huh?
Okay.
Understand?